Hello everyone. So you might know these types of sorting visualizers from these TikTok videos or these YouTube videos where they show off different types of sorting algorithms, and today I wanted to recreate something like that within C++ with raylib. And yeah, I'll just walk you through how you could program something like that yourself. And yeah, let's get started. So open up an empty C++ file, and I'll just put in the skeleton in here. And basically what we'll do is we'll create a class called sorting visualizer, like so. And in there we'll have some kind of method called main, and basically we'll call it from the main method by creating an instance like so and calling instance.main. And in there we'll have our main loop, but before creating the loop, let's actually first initialize raylib in the constructor. So let's call init window and have some kind of members for the width and height, since we'll need them when calculating the height of each bar. So let's create a const int called width, and that will just be 1000, and the same will apply to the height. Then let's substitute that with width and height, and the title will just be sorting visualizer, like so. Okay, let's set a target FPS of 60 for now. And yeah, that's pretty much it. So now we'll just have a main loop where we'll just be continuously iterating while the window shouldn't close, and we'll begin drawing like there, and we'll end drawing, and in there we'll place our draw code. Let's also pull the input events to actually be able to close the window, and let's also have a clear background with the color black, like so. Okay, so with that we have a basic setup already done. So now let's also add a member that represents the array we're trying to sort. So let's call it m2sort, and in the constructor we'll initialize this array. So let's also create an amount of elements we want to initialize this vector with. So let's call it max amount, and let's set that to 100 for now. And above here we'll initialize this. So what we'll do is we'll create a for loop beginning from 0 until max amount, and let's create a random number generator for that. Call that generator, and next to that we'll also have a uniform real distribution for floats. That's our range, and that will be from 0 to 1, like so. And to our sorted elements or unsorted elements at the beginning, we'll just place call the range parentheses overload and pass in our generator to generate some random numbers. Okay, so now we've got an unsorted array or vector of elements. So let's actually add a method that allows us to display this vector. I'm using the word vector and array very interchangeably. Yeah, but anyways, so what we should do in here is we should loop through each element in our array by going through max amount, like so. And what we should do is we should draw this like bar, the single bar. So what we can do is we can call draw rectangle. And now here's where the interesting part comes in, because this isn't as trivial to calculate as you might think. So we need to specify a position x, and basically we want some kind of x step we will be doing for each iteration, and that's just the width divided by the amount of elements we have. So let's cast one of them to a float, and like so. let's do the same for this guy. And this should obviously be a float. And basically the x position will be the x step size times the current iteration. For the y position, well, the y position will be the top left corner of our rectangle. So it will be the height minus, so the height of the screen minus the height of the rectangle. So let's call it height rect. And the height of the rectangle is the 0 to 1 value we generated times the height of our screen. So the position y will be the height minus the height of the rectangle. Yeah. The width will be the x step, and the height will just be height of the rectangle. Let's just draw it as a white rectangle. So let's try it out. You can see right here that it visualizes that properly. Now, one problem you can see is like at the top, it still displays them, and I feel like if the general bars are just a bit lower than the top, that looks more clean. So we'll just make this 90% of the height, like so, and now the top is a bit clearer, which looks better in my opinion. So now we can visualize the array. The next step will be to sort the array, and we can't just sort the array in one go, because then well, the searching visualization would be pretty fast. So we'll have to have some kind of sort step, which we'll call each frame, and that brings us one step closer to the entire array being sorted. And yeah, we'll just do that until the array is sorted. And the algorithm we'll be using is just like if you have a set of numbers, like so, what we'll do is we'll find the minimum element of this array of numbers and place it at the top or at the beginning. So we'll have some kind of right value, which is 0, and then we'll at the beginning, and then we'll go over the array. Okay, 1 is the smallest element, let's place it at the beginning, and whatever, I believe 8 was there before, we'll switch that up like so. Okay, the next iteration will be I don't know, 3 is the smallest element, so let's place that in here, and let's switch 3 and 8 once again. And now you can see the array is already sorted, so we'll make a replica of this. So we'll need some kind of static int for the right element, and this will start at 0, and we'll need to try to find the minimum index currently of the array, and the minimum index can't start at right, since well, since we know that everything to the left of right is already sorted. So we'll go over I beginning from right, I is less than our max amount, and I plus plus. And while we're iterating over that, we're trying to find a smaller element, so let's go through m to sort at the index of minimum index. If that element is bigger than m to sort at the index of I, then we know that the minimum index isn't the minimum index, so we reset it. And now we found the minimum index, so let's switch it with right, with the element at right. So let's create a temp value at m to sort at the index of right, and m to sort at the index of right equals m to sort at the index of the minimum index, like so. And then we'll just do the same with the minimum index to be set to temp, like so. And we should increment right in here. Now, if we run this, we might, yeah, we are already getting this searching effect, and along that we get an out of bounds error, since we're letting right go over the max amount. So if right is bigger than max amount, let's return like so. And with that, we've got the core functionality already done. So as you can see right here, we fixed this guy. Wait, it seems like this is still segmentation faulting. Let's try to understand why. If right is bigger than max amount, well, this doesn't work. It should be bigger or equal than, because indices are 0 based. Okay, now it works. So as you can see right here, we are sorting it properly, but we're not done yet because we want to add a bit of color to that. So let's do the following. Let's have some kind of let's mark the ones we're comparing currently or switching currently red, and once we're done, we'll just draw everything in a green color. So let's have a bool m done, and we're done as soon as right is bigger than max amount, so bigger or equal than that. So let's have some kind of color in here, like so. And if we're done, then we'll have green, otherwise you'll have white. And now let's add the color in here, like so. And yeah, you can see right here that it marks that as green. And now let's also add, let's create a std set of size t's for the compared ones. Or we could make that a pair, but I just want to make that a set. And each time before drawing the array, or before doing the sort step, let's set m compared. Let's clear that, and in the sort step, let's say that m compared at the index r will in place the minimum index in there and the right, like so. And let's draw the array before that. And now in here, if it's already done, then we're fine, but we're not always displaying white, because if m compared contains this current index, then we'll actually do red, otherwise we'll do white, like so. And now we get this cool comparison effect. So yeah, we're pretty much done. And you can see right here that we can even change the maximum amount. So let's set that to 1000 and see how this sorts it. And let's actually increase the frame rate. So let's make that 600. And now you can see right here that it sorts it very well. And yeah, you can even extend this program and, I don't know, add different types of sorting algorithms in there. But you can see right here that like this basic structure of this class is very nice and powerful. And yeah, that's pretty much it for this video. If you took something away from it or learned something new, make sure to like the video and leave a subscribe. And yeah, bye bye.